Week 5 discussion: Data Management and Business Analytics. In today's digital world, data is more than just numbers and records. It's the backbone of smart business decisions. In this unit, you'll explore how organizations manage, analyze, and leverage data to drive success. First, in Topic 1, Introduction to Data Management Strategies, you'll learn why keeping data organized, accurate, and secure is crucial. Concepts like data quality management, master data management, MDM, and data lifecycle management help businesses make better decisions and avoid costly mistakes. Then, in Topic 2, Big Data Analytics and Decision-Making, we dive into how companies use big data to spot trends, predict outcomes, and make informed choices that give them a competitive edge. Finally, in Topic 3, Technology Solutions for Strategic Data Insights, you'll see how businesses turn raw data into valuable insights using the latest tools, frameworks, and strategies. By the end of this unit, you'll understand how businesses transform data into a powerful resource, giving them the ability to innovate, grow, and stay ahead in a data-driven world. Effective data management is the foundation of any successful organization. In this topic, you explored key strategies that ensure data remains accurate, consistent, and secure throughout its life cycle. You learned about data quality management, which focuses on maintaining high-quality data to support decision-making, and master data management, MDM, which helps businesses centralize and standardize critical data across different systems. Additionally, you examined data lifecycle management, a structured approach to handling data from its creation to its eventual disposal. Understanding these strategies is essential for ensuring that data is not just collected but used effectively to drive business success. As organizations continue to rely on data for decision-making, having strong management practices in place will help them improve efficiency, reduce errors, and gain valuable insights. Moving forward, consider how these principles apply to real-world business challenges and how organizations can leverage them for better decision-making and strategic growth. Businesses generate massive amounts of data every day, and the ability to analyze and interpret this data effectively has become a key factor in decision-making. Big data analytics helps organizations uncover patterns, trends, and insights that drive smarter strategies and improve overall performance. Companies that successfully leverage data can make informed decisions, optimize operations, and gain a competitive edge in the market. In this topic, you will explore how big data analytics influences decision-making and the importance of making data-driven business choices. You'll examine real-world applications, including the impact of big data on organizational success and how companies organize and manage data for maximum efficiency. By the end of this topic, you'll recognize how data analytics is transforming the way businesses operate and make strategic decisions. Big data initiatives are critical for transforming traditional organizational decision-making into data-driven decision-making. However, prior information systems research has not paid enough attention to the impact of big data analytics usage on decision-making quality. Drawing on the dynamic capability theory, this study investigated the impact of big data analytics usage on decision-making quality and tested the mediating effect of data analytics capabilities. We collected data from 240 agricultural firms in China. The empirical results showed that big data analytics usage had a positive impact on decision-making quality and that data analytics capabilities played a mediating role in the relationship between big data analytics usage and decision-making quality. Hence, firms should not only popularize big data analytics usage in their business activities, but also take measures to improve their data analytics capabilities, which will improve their decision-making quality toward competitive advantages. 5. Organizing data-driven companies. We are living through a period of intense innovation in organizing. Academics, management consultants, and business journalists have rediscovered non-hierarchical or organic approaches to organizing, formulating variants such as Teal, 1 Agile, 2 Cellular, 3 Lean, 4 and conversational 5 firms. Since the beginning of the 2010s, corporations and management consulting companies have boldly embraced these approaches that until relatively recently seemed avant-garde. While flat organizations have been subject to academic study for at least 50 years, their newfound popularity has coincided with and been explicitly linked to the increasingly strategic role that software and data play in corporations. 7 Technology companies that rely heavily on software are disproportionately likely to have team-based organizations to distribute decision rights to teams and to emphasize employee initiative and ownership. The shift from human knowledge and insights to digital data and algorithms, discussed in Chapter 2, partially explains the decreasing need for human coordination and managerial oversight. As companies embrace the data imperative, software can carry out some of the monitoring and coordination tasks previously carried out by humans. The new strategic priorities, discussed in Chapter 3, and the ubiquitous modularity of data-intensive processes, discussed in Chapter 4, motivate and enable managers to look beyond the old bureaucratic hierarchies and matrix organizations. Real-time data and modular architectures provide the means for companies to recognize and seize new opportunities more quickly, as long as their organizational structures and processes do not prevent low-level managers from making the necessary decisions and taking decisive actions. The Dutch banking group ING serves as an example for the changes in organizational structures and processes motivated by digitalization and the new strategic priorities. ING has been a successful international player in the fairly traditional and, until recently, stable finance industry. Yet, the bank made the bold decision a few years ago to reorganize itself, adopting agile organizational structures, processes, and practices in summer 2015. Citing the importance of digital channels and potential competition from digital native firms entering consumer finance, ING began to reorganize itself into multifunctional and self-organized teams. The company configured its operations into hundreds of squads, each responsible for one or a few services, products, or business processes. These were grouped into about a dozen tribes, representing distinct domains of business, but without the profit and loss responsibilities of traditional business units. Squads have clear responsibilities and objectives that the team negotiates with the leader of their tribe. For example, one of the squads is tasked with designing and running the mortgage application process, and another with developing a mobile app that allows private banking customers to examine their assets. Even human resources are divided into squads. One such squad, for example, helps people to find and transition to new roles within the corporation. 8 The leadership at the bank argued that customer expectations of online service had changed with the quality of support provided by Google, Facebook, and others. This required ING to become far more customer-centric and to enable itself to launch new and improved products and services more quickly. The chief operating officer of ING at the time, Bart Schlattman, explained in an interview for McKinsey Quarterly, agility is about flexibility and the ability of an organization to rapidly adapt and steer itself in a new direction. It's about minimizing handovers and bureaucracy and empowering people. The aim is to build stronger, more rounded professionals out of all our people. Being agile is not just about changing the IT department or any other function on its own. The key has been adhering to the end-to-end principle and working in multidisciplinary teams or squads that comprise a mix of marketing specialists, product and commercial specialists, user experience designers, data analysts, and IT engineers, all focused on solving the client's needs and united by a common definition of success. The bank's organization is representative of the enterprise agile organizational form. Agile organizations strive to motivate and inspire employees by providing them with clear and well-specified goals, but leaving the means through which such goals are to be pursued open. The management defines the purpose and objectives for each squad, in collaboration with the broader organization, while the members of the squad have full autonomy to decide on the best means to reach their objectives. In principle, the clearly defined goals create alignment, while the freedom to implement them fuels motivation and creativity. The reasoning behind ING's transformation is indicative of the widespread changes in how managers conceive and run businesses. As the degree of automation increases, managers no longer need to monitor and control how efficiently their direct reports run the business. The strategic priorities of data-centric organizations, constant optimization through algorithms, experimentation with new services, and rich interactive customer relationships shift the focus from carrying out routines to inventing and reinventing highly automated processes. The old virtues of efficiency and predictability give way to entrepreneurialism and creativity. While ING was a forerunner in the finance industry in 2015 when it began to adopt agile organizational practices, such approaches have a longer history in internet services. Amazon, Netflix, and Spotify are just some of the well-known examples of companies that adopted speed as their strategic priority and that have relied on multifunctional self-managed teams as the primary organizational architecture of their engineering and development activities since the early 2000s. Moreover, many large corporations have been adopting agile organizational structures in their IT development units, creating oases of autonomy and empowerment insulated from the stifling matrix grids imposed on their other units. I will next highlight two central motivations to adapt organizational structures and culture: the increasing role of software and the perceived need to respond more quickly to new opportunities and demands. To explain how and why organizational structures are shaped by digitalization, I then elaborate three core goals of organizational designs: efficiency, adaptability, and coordination, and outline different organizational architectures that help accommodate these goals. Examining the emerging cultural norms and operating processes in digital organizations, I detail how the nature of managerial control, circulation of information, and basis of authority are changing in companies. The chapter concludes by discussing the broader context of the ecosystems and platforms into which corporations organize their activities, elaborating the impact of digital data on interorganizational networks, how software and adaptability motivate changes in organizational design. Digitalization creates a host of new demands for organization. To successfully leverage data and algorithms, companies must be able to adapt their internal processes and external networks rapidly and with limited cost. After all, identifying internal inefficiencies or external opportunities is of little use unless they can be acted on. In the terminology introduced in Chapter 2, the pursuit of omniscience is futile without the accompanying pursuit of omnipotence. This creates two specific demands for organizations. First, digitalization requires companies to be able to develop and deploy relevant software more rapidly. Thus, the choices managers make concerning organizational structures and processes are increasingly driven by demands of software development processes, as exemplified by ING. Second, to leverage real-time data, organizations strive to reduce the time taken by decision-making processes and the implementation of desired changes. In the contemporary business vocabulary, companies are looking to become agile. Point 10. To do so, companies are embracing new structures, processes, and cultural norms to allow more rapid recombination of resources and processes, often from multiple internal teams, subcontractors, partners, and previously disconnected companies. While greater modularity and the shift from human expertise to digital representation reduces the need for human coordination, this reduced need for coordination to run the business is offset by the greater need for coordination to develop new innovations by combining skills and capabilities across unit boundaries. The importance of software development. The opportunities to replace many human-driven processes profitably with smart automation have pushed corporations to invest heavily in software development and data management capabilities. Digital data allows companies to develop new products and services that derive their power from software, while increasing the prevalence of digital channels facilitates the rapid and inexpensive changes in user experience, again implemented through software. As the strategic role of software grows, corporations seem to be bringing back in-house capabilities that were previously outsourced. Point 11. This creates a need for companies to adopt structures, processes, and work practices that enable them to combine the talent of software developers with the industry-specific expertise of knowledgeable managers. Corporations have broadly concluded that contemporary software is best developed iteratively by fairly small teams, employing the best professionals available. Software development tools and available libraries have advanced significantly during recent decades, leading to greater productivity. In the past, software systems were always first specified, their required functionality collected in lengthy documents, and then implemented, often by distinct employees, sometimes in a different country. This old model is giving way to more integrated and iterative processes. While much of software development used to involve time-consuming coding, literally writing program code, the sophisticated programming languages and tools have increased the relative time that can be spent on the iterative design of user interactions, service specifications, and the related business processes defined by the software. These processes require diverse skills, creativity, and initiative. In software development, the quality of design is far more crucial than the ability to quickly implement the desired functionality. Programming the right thing is infinitely more productive than programming the wrong thing. The notion that software engineers vary greatly in their talents is captured by the term tensor, originating from Silicon Valley. The phrase suggests that star engineers are 10 times more productive than regular ones. This is by no means an exaggeration. Well-designed software involves far less code, fewer instructions, runs faster, contains fewer bugs, and is easier to maintain. An unskilled programmer can even be a minus tensor, creating dysfunctional software architectures and buggy modules that will eventually require an expensive and time-consuming rewrite of the system. Effective organizations and talent are far more important than numbers for producing good software. The Symbian mobile operating system, the one that dragged Nokia's phone business to death and left it unable to answer competition from Apple iOS and Google Android, provides an illustrative case study of failure. At the peak, Symbian employed over 2,000 programmers to develop the operating system. Maintaining the software was complicated by the division of the system into numerous versions running on different Nokia, Sony Ericsson, Samsung, and Motorola mobile phones. The Symbian operating system was troubled by poor initial design choices and software architecture that overemphasized processing speed over other considerations, a choice initially driven by considerations of component cost and battery size. The initial problems were only compounded when Nokia tried to solve the issues by hiring more programmers. Adding programmers to a project often increases interdependencies between teams and creates extra work. At the time, Apple developed the far superior iOS operating system with no more than 400 software engineers. The Android operating system was developed initially by an even smaller team. The tiny Android Incorporated was valued at mere $50 million when Google acquired it in 2005. Software development does not scale quite the way digging ditches does. Speeding up decision-making and implementation corporations have always been slow to change. The very sources of efficiency, the organizational routines that make workers efficient, often lead to rigidity. The traditional bureaucratic corporations are inevitably slow in developing new ideas into products and bringing them to market. Until recently, corporations were relatively comfortable with rigidity and, sometimes, a glacial rate of change because they had other more important strengths on which they could rely. Large companies could achieve superior competitiveness through scale-based efficiency, typically by developing management structures and organizational routines that minimized costs and maximized quality, which, in the corporate context, meant predictability of outputs. This involved control of supply chains, the development of valuable brands, and constant reduction of costs that small firms could not match. While greater efficiency has tended to shield corporations, such as big banks, from more nimble competition, digitalization has allowed small startups with limited resources to create mobile apps and web services that challenge established corporations. As products and services can now be marketed and delivered through digital platforms, large corporations are losing the advantages they have derived from their physical infrastructures, particularly when bringing new offerings to the market. This is exemplified clearly in the banking sector and the concerns underlying ING's organizational upheaval. Despite their resources, big banks were, first, caught unprepared by the internet-based payment and investment services, Betterment, Klarna, PayPal, Wealthfront, and, more recently, by the mobile-first services N26, Robinhood, TransferWise. Speed matters because competitors can scale up their activities much more rapidly than before. Digital technologies allow new services to be rolled out to existing customers instantly on a global scale with little or no cost. For example, while old-style retailers would require significant investments and months of planning to revise the design of their store network, a small team at Amazon can now easily change how Amazon presents its products on the website. Developers can pilot their designs in series of small-scale experiments to test them before rolling out the best new designs globally. As digital technologies reduce the cost of implementing changes, human organization and decision-making processes become the major barriers for experimentation and innovation. In traditional corporations, change initiatives are often delayed by hierarchical approval processes and the need for lateral coordination among managers from diverse units, many of whom have no real incentives to address the issues outside their direct responsibilities. Approaches to organizing in the digital era: efficiency, adaptability, and coordination. While consulting companies have heavily promoted agile and digital organizations, the truth is that corporations use diverse structures to pursue digitalization. In many industries, the agile team-based organization that ING copied from Spotify and other internet companies may well be inferior to the matrix organization. To make sense of the alternative organizational forms, it is useful to consider the goals they were developed to pursue. Every organizational form is geared towards achieving certain goals, while it is necessarily worse in terms of some others. Examining the key choices underlying alternative organizational designs helps understand when and why companies adapt their structures in response to the increasing importance that software and data play in their business. Figure 5.1 summarizes the core goals that motivate the choice of one organizational form over the others. Figure 5.1 Key objectives of organizing and the generic organizational form's efficiency of routine work tasks, depicted at the top of the figure, represents the central determinant of competitiveness throughout much of the 20th century. To achieve lower costs than competitors, companies had to focus on getting the most out of every employee, often through increased specialization and routinization. The bureaucratic hierarchy enables ongoing improvements through a clear division of responsibilities, large units with economies of scale, and easily measurable goals. The structure further enables the top management to exert cost controls and maximize efficiency across departments, teams, and individual workers. In bureaucratic hierarchies, units have clear and distinct responsibilities that can be reliably measured, often in monetary terms. This helps align the interests and incentives of middle managers and their subordinates with the company's overall performance. The structure is ideal for pushing the whole organization to improve their effectiveness and to cut costs. Gradual increases in the efficiency of routine work should naturally increase the overall performance of the company, enhancing its ability to sell more of its products or services for a greater profit. However, there is one significant caveat: doing the same processes faster and cheaper is only beneficial when the task demanded from employees remains fixed. German car companies are the most efficient in making high-quality diesel engines. The ability to cut defects and costs served the car companies well throughout the 20th century. However, gradual increases in efficiency will provide very limited advantage if profits are suddenly to be found in selling electric cars instead. If the data imperative is shifting the locus of strategy from gradual increases in efficiency towards experimentation with new products and services, bureaucratic hierarchies are quickly losing their appeal. Accordingly, many companies pursue adaptability, depicted on the bottom left of Figure 5.1. Adaptability represents, broadly, the company's ability to redefine what it does and to realign its activities to pursue new goals. The archetypal adaptive organization is the startup, a small organization that is led by a charismatic visionary entrepreneur with significant centralized power. 12 The startup form has inspired corporations to set up internal incubators and startup ventures. 13 Centralization of decision-making power and responsibilities creates significant risks by making success essentially dependent on one person, but it also eliminates the many delays that derive from formal processes, organizational politics, and horizontal coordination across managers. Although startups are full of energy, they tend to lack efficiency, especially when they grow in size and the founder can no longer control and coordinate all key activities. The lack of proper hierarchical structures and management control systems creates flexibility, but also leads to needless duplication of effort and pursuit of divergent and often conflicting goals across teams. Autonomous teams may also be more likely to engage unwittingly in unlawful or unethical behaviors because, together, the lack of deep functional expertise and the emphasis on speed may lead the team to overlook potential issues. Entrepreneurial leaders can generally coordinate and oversee activities effectively as long as they can maintain personal social ties to the most important employees. This becomes increasingly difficult when the size of the company grows beyond 60 to 120 employees. Most innovative and successful startups add more structure to increase efficiency, eventually growing up to resemble the corporations they were set up to disrupt. Stated in reverse, many large and bureaucratic corporations began their lives as chaotic startups. The bottom right of Figure 5.1 contains the third central goal: coordination of interdependencies. As discussed, startups handle coordination through the social ties of the founder, while bureaucratic hierarchies depend on the division of labor and formal processes to minimize the need for coordination. Yet, both of these are somewhat problematic approaches to coordination. Businesses that handle complex projects or that need to coordinate adaptive changes with established work processes have developed organizational designs that are particularly suitable for coordination, variably called the Networked Organization 14 or Network Organization. Point 15 Academics who studied large companies that develop and leverage complex technologies had already noted the presence of these new structures in the 1980s and 1990s. These companies manage coordination needs by emphasizing shared values and tight social networks that cross the horizontal and vertical divides of traditional bureaucratic forms. Digitalization can increase the importance of coordination, as real-time data flows allow different processes and services to be connected intelligently to one another. The global reach of digital services and the shift to business models that emphasize holistic customer-oriented solutions combine to push corporations to improve their internal collaboration. Internal social networks and chat rooms are now common tools in both startups and established corporations to support networking across units. While tools such as Slack, a digital chat service, and a multi-billion-dollar Silicon Valley company that went through an IPO in 2019, can be adopted by startups and bureaucratic hierarchies, becoming a real network organization requires the company to establish strong lateral ties and collegiality, and to provide a high degree of autonomy to professionals that enables them to collaborate spontaneously. Such improvisation seldom takes place in corporations that impose stifling performance targets on their employees and teams. Each of these three archetypical forms serves its main goal effectively, but scores poorly on other aspects. While functional organizations provide efficiency, they are equally bad at adapting to environmental changes and coordinating complex interdependencies across functions. Startups may be able to adapt, but without clear structures, they cannot effectively coordinate activities and improve their efficiency as they grow. Network organizations may help coordinate complex interdependencies, but their reliance on shared values and redundant network ties means that they are neither efficient nor truly adaptive. To alleviate these problems, organizations can rely on a number of other more complex structures. I will next review 3 approaches that try to strike a balance between 2 of the goals. Structures that balance multiple goals beyond the 3 basic approaches to organizing discussed. Figure 5.1 depicts 3 other common approaches along the edges of the triangle: matrix organizations, teams of teams, and ecosystems of companies or internal profit centers. While all of these forms predate digitalization, they are also commonly used to pursue digital strategies. The classic matrix organization, depicted on the right-hand side of the triangle, is literally the organizational design of the space age. It was invented by the U.S. space program in the 1960s. The structure is essentially a combination of 2 interrelated hierarchies, typically based on functional domains, such as marketing, manufacturing, and technology development, geographic domains, product areas, or customer groups. such as business banking and consumer banking. The structure is designed to pursue multiple goals that are often imperfectly aligned, such as cost efficiency along specific functions and alignment of activities along product lines. For example, a car company with a matrix structure would have one hierarchy of functional managers that oversee efforts in each function, such as design, manufacturing, and sales across all car models, and another hierarchy of managers running different product lines. The functional hierarchy would optimize costs and reduce duplicate efforts by coordinating activities across product lines. The product line hierarchy would coordinate activities across functions to align the design, manufacturing, and marketing efforts for each car model. The structure strikes a balance between efficiency and coordination. From the 1970s onwards, many corporations have found the matrix structure to be a highly effective way to organize their business, and it is still a popular approach. However, when faced with significant environmental turmoil, matrix organizations struggle to adapt. In a matrix structure, every employee has two bosses, which severely limits employees' ability to initiate changes or to improvise. Matrix structures tend to rely heavily on well-defined goals that often thwart attempts to react quickly to emerging opportunities. Strong interconnected business goals easily lead to chronic avoidance of emerging responsibilities, with managers more interested in passing the buck than serving new customer needs. Many industries have evolved into networks of collaborating companies to accomplish both efficiency and adaptability, depicted on the left-hand side of Figure 5.1. This approach has a long history in diverse industries including, most prominently, the construction industry, fashion, and various fields of entertainment, including musicals, theater, and film. Networks accomplish efficiency through constant Darwinian competition among small firms. Customers can purchase tasks from providers that provide the best value for money. Adaptability is similarly accomplished through distributed innovations made by firms competing for customer attention, as well as flexible changes in the configurations of supplier buyer ties and partnerships among the firms that recombine firm-specific capabilities in new ways. Industry networks are often concentrated into geographic clusters. Point 16. While the network approach has served these industries well, small networked companies often thrive in predictable industries that do not require large capital investments. The lack of effective coordination mechanisms to guarantee future revenues and the volatility faced by individual firms makes significant investments too risky. The final structure at the bottom of Figure 5.1 I have called Team of Teams, from the book of the same name by McChrystal and co-authors. Point 17. This organizational structure, preferred by many information technology companies, is based on interconnected and relatively autonomous teams. This approach has been also called Agile Enterprise and closely resembles the various approaches mentioned in the opening paragraph of this chapter. Team of Teams organizations pursue the adaptability of startups along with the coordination of networked organizations by dividing tasks into fairly autonomous, multifunctional teams. Given the increasing popularity of team-based structures across industries, it is important to note that these approaches are generally poor at controlling the efficiency of routine tasks. Team-level autonomy limits the use of strong management controls of bureaucratic hierarchies, while the emphasis on cross-functional collaboration limits the efficiency benefits from the division of labor. Team-based structures are sensible only because there is little routine work left in many corporations. Digitalization promises to automate routine tasks and eliminate recurring human work. One company that swears by small teams is the Finnish mobile gaming powerhouse Supercell, the developer of some of the world's best-selling mobile games, including Clash of Clans and Clash Royale. The CEO and co-founder, Ilkka Paananen, has noted that the company has consciously tried to retain its small size, even at the expense of growth and profits, so as to be able to operate through autonomous teams with strong mutual ties to one another. In 2016, the company was able to generate more than €2 billion in revenues while employing only 213 employees. The company website explains, "We've found that the best quality work comes from small teams in which every single member is passionate about what they do." Oftentimes, when teams become bigger, processes, bureaucracy, and even politics emerge, and the work just isn't fun anymore. That's why we wanted to create an organizational model made up of very small teams, or cells, as we call them. Supercell is a collection of these cells. Each game comes from a cell, and they all operate extremely independently and have complete control over their own roadmap. Our organizational model is optimized for speed and passion, not for control. Point 18. While team-based organizations are often called simply agile, I decided to use the label team of teams instead. It nicely captures a key insight from McChrystal et al. 2015. While team-based structures are naturally adaptive, coordination among teams is a hard-won accomplishment. Team-based structures can be made more adaptable simply by giving expert teams significant autonomy in choosing how to pursue their goals, thereby enabling rapid experimentation. Yet, coordination across teams is generally difficult due to very basic social psychological dynamics. Teams tend to naturally develop a strong primal us versus them attitude, attributing accomplishment to their own greatness and setbacks to the maliciousness or incompetence of other teams. McChrystal et al. Argue that teams must feel that they are part of a bigger team of teams, which can be achieved through widespread social networks that span teams. To form a team of teams, McChrystal et al. Recommend that every team should have members that, on aggregate, hold personal ties to at least one person from every other team. Such fairly sparse, but widely distributed networks help teams see problems and solutions from the other team's perspectives, suppressing conflict and facilitating coordination. The team-based approaches and their benefits are well covered in many excellent books on building agile organizations, elaborating the purpose and key principles of squads, chapters, and tribes, into which these organizations are now often structured into. Point 19. Rather than elaborating the current practices of agile organizations, I will point out some of the limitations and key factors those looking to work in such settings ought to consider. In my mind, many established organizations, wishing to become nimbler and more innovative, have been overly enthusiastic to adopt agile structures as a miracle cure without attending to the unique demands that doing so places on both employees and managers in comparison to more traditional hierarchical structures. The agile structures assume that members of each team take shared responsibility for the goals and the mission statement that they negotiate with management. The team should maintain relationships with other teams to develop interactions and manage interdependencies that the pursuit of these goals requires. This approach makes three assumptions, none of which can be taken for granted. First, the adaptability of agile organizations is dependent on the ability of the organization's leadership to set and constantly update appropriate goals. Self-managed teams have the autonomy to pursue their goals as they wish, but their success puts a far greater weight on the vision and insight of top management. Second, the additional coordination requirements with other teams should not deplete the energy and time available for innovation. While the idealized view of an agile organization is one of apolitical innovators working together, organizing inevitably brings about power and politics. Bureaucracy, with emphasis on shared rules and procedures, is generally more capable of keeping political scheming and favoritism in check than a team-based structure. Third, the members of agile teams must have the ability and willingness to share end-to-end responsibilities, negotiating their goals, choosing how to pursue them, and making sure they are adequately reached. Not every employee wants to have such responsibilities. The majority of individuals who have pursued secure non-managerial jobs in large established corporations are not aspiring entrepreneurs who have only been held back by the bureaucracy. I was surprised by how many executives that I interviewed went to great lengths to convince me, and I expect, themselves, that all their employees are delighted to have greater responsibility. Despite these words of caution, a large share of successful technology companies have organized substantial parts of their workforce in cross-functional teams with significant autonomy. Despite the challenges, established organizations should be careful about assuming that all their expert staff are particularly motivated or prepared to think like owners and be part of an entrepreneurial team. Their best bet probably is to cultivate units with such motivated talent. This has been particularly challenging for established corporations that have historically prospered through low-cost strategies and have thereby developed an aversion to providing employees with substantial bonuses. Other common problems include unwillingness to pay subordinates greater salaries than their superiors earn and the common tendency to relate managers' compensation to the number of subordinates they have. Both norms seem reasonable at face value, but they're actually detrimental to corporate success. Supercell above shows how a visionary team leader with a dozen world-class experts can now create a business with $1 billion in annual revenue. Such success would be unlikely in a corporate culture that nudges ambitious talent to amass hundreds of subordinates in order to obtain promotions and a meaningful compensation. Mixing it up. Hybrid responses for complex challenges. You are unlikely to find any large corporation that adheres single-mindedly to any of the organizational forms depicted in Figure 5.1. In practice, companies mix and match different approaches to organizing depending on their teams. ING itself runs risk management and core finance processes in a traditional hierarchical organization in order to minimize risks and assure predictability. Similarly, while Google's engineering organization consists of interconnected teams, its global sales organization is far closer to a hierarchical structure. Many multinational corporations that rely on matrix structures for their core operations have reorganized their software development in agile team-based structures. I found that established corporations undergoing digital transformation often exhibited a mixture of very different organizational cultures and processes. Over time, the corporations had developed highly effective organizational structures that they were wisely reluctant to disrupt. They implemented agile structures and work processes in few selected departments, often with narrow responsibilities for service development activities. Given their low margins and fierce competition, corporations recognized that disruptions to their main businesses could threaten the very survival of the company. This approach was not without its own problems. My interviews suggest that agile teams often find it difficult to secure support and to collaborate effectively with managers and experts working in the mainstream, hierarchical, or matrix organizations. Negotiations and collaboration across these different approaches to organizing are complicated by the very different approaches they have towards incentives and control, two of the themes addressed in the next section of this chapter. Several organizations I interviewed responded to these challenges by shielding the agile organization from the power and politics of the old mainstream organization. Eliminating power to influence other teams' agendas is often a viable and efficient way to manage interdependencies, but it inhibits genuine coordination that would often improve organizational outcomes. One large European bank I studied illustrates a typical hybrid approach, where agile structures are used for teams tasked with developing new applications and software-driven processes that are subsequently operated by traditional hierarchically controlled business units. The operations of the bank were organized as efficient country units, with a hierarchical organization responsible for major customer groups and product domains. The hierarchical organization closely monitored the routine work, making sure the services maintained a high quality and a high level of productivity. The chief digital officer of the bank described to me how the firm had adopted agile practices and delegated power to teams within their development organization. The development of new processes was highly adaptive due to the autonomy and decision-making power delegated to teams. The development organization relied on the leaders of domain-specific hubs and special face-to-face planning days involving all development teams and representatives of functions to coordinate their activities. These large face-to-face events are part of the popular Scaled Agile Framework, SAFe, commonly known as Program Increment Planning workshops. This division of labor between developing and operating data-driven processes had clear advantages, but also clear disadvantages. The development teams had no direct responsibility for the business outcomes of the software they developed, whereas the country organizations lacked the ability to adapt and improve the software-based processes that they operated. For example, one development team had created functionality in the mobile app that allowed users to book an appointment with an investment advisor at the bank's local branch. The service, once developed, was handed off to retail banking organizations in various countries. At this point, nobody in the corporation held responsibility for the usefulness or value of the service. Were the team also responsible for running the service, they could have used the digital data it accrued to optimize the functioning. It is quite possible, for instance, that customer characteristics can predict the financial implications of a meeting with an investment advisor. The mobile app could advertise the opportunities to book an appointment only to those customers who are likely to create new revenue. Moreover, the timing of notifications may have significant implications for the likelihood of booking the appointment. The services could well be in higher demand at the time customers receive their pay, or even annual bonuses. When the development and operation of services is divided to distinct organizations, the sense of ownership and responsibility for the services may be lost. The need for diverse structures is far from new. Corporations have traditionally struggled to find a balance between operational efficiency and blue-sky innovation, two important goals that have traditionally required distinct management systems and organizational cultures. Academic research has dubbed this phenomenon ambidexterity, and identified companies that predominantly solve the conundrum through distinct units with their own management systems and cultures. 20 corporations have long assigned mainstream business into specialized units with sufficient scale to achieve operational efficiency and integrated diverse expertise in cross-functional teams so as to foster innovation. 21 The cross-departmental and cross-functional teams are often funded by separate venturing units or innovation labs that help them to pursue more radical ideas. Digitalization seems to be breaking down both sides of the old model of an ambidextrous organization. With smart automation, having a large number of effectively managed employees is no longer a guarantee of faster learning and greater cost savings. Moreover, as modularity enables innovators to leverage existing data assets and business processes, it no longer makes sense to push innovation teams into separate venturing units or innovation labs, detached from the mainstream organization and workforce. Many data-driven organizations of the 21st century seem to reject the tension that is supposed to exist between efficiency and innovativeness, particularly the old notion that cost-effective and innovative organizations require very different cultures. Due to a high degree of automation, companies can pursue efficiency through continuous innovation. Instead of separating development and operations, companies such as Amazon and Spotify assign the ownership of business processes to small teams that have a large degree of autonomy in redesigning them. Teams have responsibilities to run and continuously develop processes, often by leveraging digital data flows and smart algorithms. When the organization comes up with a new idea that requires more time or resources, it forms a new parallel team with less operational responsibilities to pursue it. The combination of different approaches to organizing also requires diverse skills from the top management team, a classic insight of the ambidexterity perspective. Accordingly, companies must develop and nurture distinct kinds of processes and cultures for efficiency-oriented units that require routine human work and innovation-oriented, explorative units for processes that can be fully automated. Top management requires diverse skills to negotiate tight goals for the efficiency-driven units, while providing direction and guidance to the software-centric units. Top managers must also often closely manage the collaborative relationships and transitions between these very different parts of the organization. 22 The culture and processes in digital corporations. If it were sufficient to change their organizational structure, corporations would have no trouble responding to digital transformation. After all, new reporting structures and roles can be rolled out quite easily. Through my interviews with established corporations, I noticed that 3 factors stood out as central stumbling blocks to becoming agile. While my informants used diverse terms to depict these changes, I summarized their observations as new approaches to 3 distinct domains: managerial control, circulation of information, and authority. Mechanisms of control, from predictability to ethos economics, has provided one of the most powerful and influential views on organizations as structures of governance. This perspective derives from the observation that incentives can easily become misaligned and human individuals may act opportunistically against the interests of their superiors. In short, the incentives of the superior, principal, and the subordinate, agent, tend to be misaligned at every hierarchical level and thus need to be governed. Owners nominate boards of directors to govern the top management team, while each manager across the hierarchy seeks to govern the activities of their subordinates and make sure they are working towards the same goals. In traditional organizations, governance has been accomplished through three interconnected mechanisms: goal setting, incentives, and monitoring. These three mechanisms help align the focus of subordinates with their superiors, motivate alignment, and track that it is accomplished and maintained. These governance structures accomplish another goal that has great psychological importance. They create predictability. Again, the pursuit of predictability runs through the hierarchy. The top management team promises annual and quarterly results to investors and sets budgets for business units. Business unit heads set out key performance indicators, KPIs, for heads of departments who commit to revenue and cost targets. The department heads unpack their own KPIs to team-level objectives, imposing the same demands for predictability down through the hierarchy until the expected performance targets of every individual have been meticulously laid out. The purpose of this elaborate goal setting, incentivizing, and monitoring is to take ownership of the future and banish uncertainty. The inherently unknowable future is made to feel predictable, while the organization signals the seriousness of its managers in securing future performance. The process described above is familiar to every MBA graduate, and it has served companies well. But it is inherently ill-suited to innovative and fast-moving companies, as Eric Schmidt, the former CEO of Google, and his co-authors Jonathan Rosenberg and Alan Eagle describe in their book How Google Works. When corporations take control of the future by means of budgeting and KPIs, their efforts to eliminate unpredictability often also eliminates radical innovation. Of the organizations I interviewed, several professed to running self-managed teams with strong KPIs, which hampered exploration within teams and collaboration across teams. To understand how the mindset of corporate control can shape exploration, consider how self-managed teams negotiate their goals. When the top leadership is focused on minimizing unpredictability, self-managed teams will almost certainly try to set goals that they know they can achieve and already have a viable plan to accomplish. In a strict performance management world, teams generally lack motivation to pursue radical innovations. A team that pursues a high-risk project to cut operating costs by 90% through an AI solution can lose its bonuses if it fails, while a success will simply be rewarded with more ambitious goals for the next quarter. The very process of control that reduces the uncertainty superiors have about their subordinates prevents exploration and directs teams to the sweet spot of objectives that look difficult but are easily doable. Point 23 Schmidt et al. Explain how, instead, managers at Google aim to set goals that are almost unattainable and worry that teams are not thinking big enough, rather than missing their goals. Instead of KPIs, Google uses objectives and key results, OKRs. An approach pioneered by Intel. Point 24 The idea of OKRs is to replace performance metrics with broad, motivated objectives that are accompanied by measurable, unambiguous key results. The purpose of key results is to drive behavior, but the team or individual is not necessarily assumed to accomplish them. Consider, for example, two of the objectives set at Google: to increase the messages users post in Google Hangouts and reduce latency of YouTube videos, both associated with very high quantitative targets. These were aspirational goals that would provide significant benefits if achieved, but that could not be reached without significant innovation. Employees were not expected necessarily to reach the key results, but they were expected to give it their best try. Ironically, the OKRs preferred by technology companies are less data-centric than KPIs typically in use in traditional corporations and public organizations. Whereas KPIs provide predictable and objective rewards for employees, often predetermined bonuses that are tied to performance, OKRs tend to be associated with more vague and retrospective performance appraisals that rely on subjective assessment of the efforts. Promotions and bonuses depend on an overall review of past accomplishments, and managers must be able to assess the initiative and innovativeness of their employees in addition to their measurable results. The predetermined incentive structures of KPIs are excellent for driving desired behaviors, but many employees and lower-level managers that I interviewed identified them as one of the key barriers to digital transformation. The main reason was their toxic effects on collaboration. The very advantage of KPIs to direct employee attention to what matters means that employees have little time or motivation to address issues outside their narrow mandates. My informants told me that efforts at digitalization had pushed their companies to launch new development initiatives that cut across established units, but that these initiatives were largely thwarted by the established KPIs that pushed the development projects to the bottom of everyone's priority lists. Management consultants often profess a strong belief in performance metrics, and I have been told that all the problems associated with quantitative metrics derive merely from their poor design. While it is possible that perfect performance metrics could be designed to facilitate complex cross-unit collaboration projects, they would still work against the very idea of agility. If an organization needs to reconfigure its structures or incentives to implement changes, it is not agile. Speed comes from being able to identify opportunities and to pursue them rapidly, unhindered by managerial efforts to make the future fixed and predictable. The diverse principles and practices of agile organizations, inspired by the Agile Manifesto 25, can also be viewed as efforts to eliminate and minimize hierarchical and bureaucratic, rules-based controls over development activities, prototypically software development, but also business development efforts more generally. Companies have found that they can delegate decision-making powers to the very teams that implement changes and shield these teams from external disruptions by simply trusting the team and granting them greater autonomy. The governance shifts from monitoring to trust. The withdrawal of managerial control also stems from the decreasing need for managerial coordination of work across individuals and units. The complex interdependencies that arise between different services can now often be controlled with software, reducing the need for middle managers. In a sufficiently digitalized corporation, there is little need for departments to hold meetings to coordinate their established activities. Changes in one department's operations are encapsulated into modular organizational design and connect seamlessly to other departments' activities. For example, Spotify has divided its organization into a few dozen teams that are responsible for different modular aspects of the product: web app, search function, new music discovery, data storage, data transfer, user enrollment, payments, and so forth. Each team can change its operations without requiring adjustments in activities run by other teams. When mutual adjustments are needed, the organization tries to do them without involving hierarchy. Teams can implement changes directly to the software code being developed by another team, with the owning team reviewing and approving the changes. 26 The greater the autonomy and the ability of teams to design and implement changes, the less the time required by decision-making processes. Modular architectures and well-defined interfaces between teams enable them to achieve greater integration with less human interaction. The phenomenon has been dubbed the vanishing hand hypothesis, the proposition that modular architectures help companies avoid coordination between teams through the visible hand of managers. 27 In summary, digitalization has reduced the need for managers to control and oversee the decisions and efforts of experts. At the same time, the experts have become less dependent on explicit managerial support, traditionally a key determinant for the ability of frontline employees to develop new innovations. 28 Whereas autonomous and disconnected teams have traditionally been unable to leverage the firm's existing capabilities or even access customers, digitalization has increased modularity and brought about internal application programming interfaces, APIs, see Chapter 4, that empower small teams to combine and connect processes across the enterprise, enabling them to develop user-facing functionality and valuable internal processes without substantial support from either top management or other teams. These recombinant innovations can create significant value or cost savings with modest effort. Cultures of transparency and the social media organization. The paradigmatic shift from human knowledge to digital representations allows companies to share a rich view of all business processes and customer behaviors across the organization. Such radical transparency can be a valuable source of innovation, as it empowers all employees to identify and analyze unmet customer needs and suboptimal processes. This also means that the cost of organizational secrecy has increased greatly. When I started writing this book, I read a number of books on digital native organizations and conducted interviews at various Finnish and UK corporations in order to understand how they use data. One of the key insights that emerged early in my research was the stark difference in how information circulates in digital and pre-digital companies. Every single established corporation that I interviewed exhibited, to a varying extent, a culture of secrecy. They believed that the spread of information about revenues, customer behaviors, budgets, and, particularly, profits should be contained both vertically and horizontally. Information tended to be confined to business units that were not only information silos, but also political fiefdoms. One vice president told me that even though he would be able to receive information on revenues and customer-specific profit margins from adjacent business units, he would be reluctant to ask. It would look rude to be poking my nose into their business. One sales manager at a telecommunications operator told me that he could see all the purchases made by his corporate customers, but had no information about the profit margins of the various services. A follow-up question revealed that all the purchases did not include any of the services provided by other business units of the company. How are salespeople supposed to be customer-oriented if they do not even know what services their own company is currently providing to the customer? How can employees think like owners if they have no idea about the profit margins? This culture of secrecy was so deeply ingrained in the companies I studied that it took a while before managers even recognized it. At one service company, the customer service department was unable to provide information about customer service calls to the marketing department. The supposed technical difficulties in sharing this simple information conveniently prevented anyone in the corporation from examining the financial impact of poor customer service interactions that had led to canceled contracts. The corporate culture was one of respectful ignorance. It was deemed unbecoming to spy on what other managers were doing. In a classic corporate world, it has been irrational for managers to share detailed digital data of the processes and outcomes accomplished by their units. The ability of others to scrutinize business processes seldom provides any direct benefit for the manager, while it can be a potent source of embarrassment. By keeping the data behind decisions hidden, managers reduce the likelihood that their decisions will be challenged. As human knowledge is being supplanted by digital representations of the world, managers can try to retain the value of their expertise and insights by hiding data and postponing efforts to integrate information systems. Intuitively, the pursuit of digital omniscience and the insights it creates about business processes, the operating environment, and customers are squandered if the data is not widely used throughout the enterprise. Yet, in most corporations, the average employees are aware of and have access to a fraction of all collected data. If employees are expected to create new services and more effective processes, then digital data has to be widely available to them. I was thus not surprised to learn that in-depth accounts of the culture at digital native companies such as Facebook, Google, and Spotify highlight their pursuit of widespread internal transparency in their operations. This was especially true of accounts that preceded each company's IPO, a point at which insider trading rules imposed new limits on enterprise-wide data sharing. While transparency comes with significant risks, including knowledge leakage, heightened conflict, the politicization of budgets, and envy, the costs of secrecy outweigh the benefits. Without transparency, coordination becomes a challenge. Employees are unable to identify and analyze opportunities, and the sense of ownership is less likely to develop. Professor Catherine Turco recently published an ethnographic study of a radically transparent software company. 29 The informants observed that transparency simply seemed appropriate for the workforce belonging to the social media generation. One manager even proposed social media as the core metaphor for the culture of and practices in the company. This transparency was accomplished mainly through digital chat rooms, a wiki, and physical question and answer sessions. These channels allowed executives to share comprehensive information to all employees and to solicit open discussion. The leaders rationalized that transparency would turn the company into a collective brain, enabling every employee to search for, use, and contribute to conversations and shared knowledge in much the same way as social media users. Turco, 2016, 72, notes, Whereas the 1990s network metaphors implied horizontal collaboration and distributed authority, and thus suggested the fluid, project-based hierarchies written about at the time. Social media suggests above all platforms for voice and conversation. Radical transparency was taken to an extreme level, with executives openly sharing even typically confidential investment information, such as the company's full financial history, including the number and price of shares issued to venture capitalists in each round of financing and the company's valuation at each of those rounds. Executives from other companies told Turco that such openness was unheard of, one venture capitalist noting that "I would fire whoever shared such information." Transparency signaled to employees that the managers respected them and made them feel involved in the success of the company. Professor Turco highlights that transparency and space for open debate and question is not the same as democracy. The company was atypical in providing access to information to all employees and in allowing them to voice their concerns and openly to question decisions made by the top management. Yet, the employees had no more decision rights than employees of traditional corporations. In traditional industrial corporations, these three states have been closely connected. Decision rights determine what information you are allowed to access and the topics on which you were able to voice your opinions. In the firm she studied, everyone could view and comment on decisions in the company wiki, but there was no doubt that most decisions would be made by the top management and that the employees would accept and follow them. The culture of transparency extends from the workings of the organization to its external boundaries. While the contemporary data-driven corporations hold valuable proprietary knowledge that they guard from their competitors, they nonetheless often lack the obsessive secrecy of the 19th and 20th century corporations. For example, Facebook, Google, and Microsoft quite remarkably encourage their scientists to share much of their work openly in academic journals. For example, Google scientists Jeffrey Dean and Sanjay Gamawat published the seminal MapReduce algorithm that provides the technological basis for distributed computing in Google's data centers. The algorithm was first shared at a conference presentation in 2004 and, subsequently, as a journal article in 2008. It has since been implemented in the open-source software Hadoop. The publication has become one of the most cited articles in computer science, with over 16,000 Google Scholar citations as at December 2019.30. Moreover, several of the vice presidents in these technology behemoths work part-time as computer science professors in prestigious universities, disseminating the technological advances in artificial intelligence and distributed computing. In this sense, Apple is somewhat of an outlier among the large technology companies in its commitment to secrecy both towards the outside world and within the organization. Unfortunately for established corporations, the shift from secrecy to transparency can be difficult. To begin with, many managers have navigated long careers by using secrecy to their advantage, recognizing information as a resource in internal negotiations and as a generic source of power. Moreover, openness can have devastating effects in organizations that are used to political struggles and intergroup conflicts. One colleague told me how a new accounting system at his university suddenly allowed every head of department to scrutinize the budgets of all other departments, even across schools. Predictably, this created political fights, where departments demanded to know why they were not granted the same resources as others. Sources of authority, from position and expertise to situated performance, the greater speed of change has led to a more fluid reconfiguration of collaboration relationships and interdependencies in organizations, heralding changes in the foundations of authority in the workplace. The formal position, length of tenure at the corporation, and personal charisma have been traditional sources of authority in companies. Throughout the course of the past century, deference increasingly came to depend on expertise, the record of accomplishments, and position in informal social networks. Yet, digital transformation is now challenging all of these established sources of authority. A study by 3 Canadian professors, Alaric Bourgouin, Nicholas Bencherki, and Samer Faraj, elaborates the need for a further reconsideration of authority in the post-bureaucratic organizations of the 21st century. 31 Authority, these professors observe, can no longer be derived from one structural position when organizations take the form of fluid and ever-changing networks. Instead, authority, defined as the ability to direct collective action, is an attribute that individuals must create in their interactions with others. It is not something managers have, but something they perform. This notion has great resonance with my interviews, and the reasons for the shift are easy to understand. Since digital data flows bridge diverse parts of the firm and require new lateral collaborative relationships, position can no longer bring authority. With new technologies and the faster pace of change, tenure and past accomplishments come to matter less. While expertise provides some authority, the need to collaborate across different domains means that employees increasingly deal with people who may not recognize their expertise. And in any case, as Borgwin et al. Argue, management as a field lacks a readily recognizable body of professional knowledge that would allow a manager to claim expertise. While charisma and rhetorical skill are always likely to remain important sources of authority, they are seldom sufficient outright to win sustainable deference from technical experts in challenging innovation projects. But if these sources of authority no longer work, how do employees get others to play along? After all, the ability to influence others and direct collective action is central to the successful implementation of any development project. Borgwin et al. Argue that authority is now increasingly performed in real time and often tends to be confined to distinct kinds of relationship. 32 Influence is created in and transposed across situations. 33 To gain influence over individuals and groups in a specific situation. Managers can draw on diverse networks of resources that include humans, facts, symbols, and ideas. The authors document how management consultants gained authority in an organization in which they had no formal position by strategically enrolling allies to advance their perspective, referring to abstract principles and topical ideas, and using material artifacts such as established tools or specific analyses to convince others. These practices should be familiar to anyone in expert work. To make changes happen, we enroll allies. We evoke slightly faddish terminology, such as design thinking or microservices architecture, to encourage others to buy into our vision, and we brandish various tools and reports to convince others. Data-driven companies are not unique in the central role that performed authority plays. The ability to convince others has always been important in organizations. Instead, many are distinguished by the relative scarcity of stable and attained sources of authority. Crucially, the ideas and artifacts that grant actors authority in these organizations increasingly involve algorithms and data. To gain authority, managers approach problems using either well-established or technologically superior approaches and provide raw data and analyses that support them. Running experiments is the ultimate source of authority in data-driven businesses. They signal significant commitment and create convincing evidence that others cannot easily dismiss. The ability of would-be innovators to use exciting ideas and data-driven analyses as sources of authority hinges on company culture. Many company cultures reinforce the structural basis of authority: formal positions, firm tenure, technical expertise in the core domain, established social networks, and past accomplishments. Even as digital strategy is pushing companies to develop new kinds of business process where they have no direct relevance, it is still common for corporations to base their decisions on the highest paid person's opinions, hippos, to use a trendy term. Point 34. It is very difficult to achieve agility if the company culture is reinforcing the structural sources of authority and preventing employees from flexibly drawing on people, ideas, and data to mobilize and orient collective action. Organizing beyond the firm, ecosystems and platforms beyond the internal organization of corporations. Digitalization shapes how companies interact and collaborate with one another. In the pre-digital era, collaboration among companies often required social ties, trust, geographic co-location, and the development of organizational routines that spanned firm boundaries. As firms have developed increasing modular structures with digital interfaces, services across firms can now be coordinated with software. The industry-wide changes created by digitalization are often described by two important terms: ecosystems and platforms. Ecosystems in business refer to groups of interconnected companies and non-commercial actors, such as the state, that engage in value-creating interactions and mutual coordination that are neither purely hierarchical nor directly tied to market exchanges. 35 Business ecosystems are common, but they vary greatly in their scope. All product markets with complementary products or services that are designed to work together by distinct firms without classic buyer-supplier relationships between them are ecosystems. Photography in the 20th century represented a business ecosystem that consisted of camera producers, makers of film that was designed to fit the cameras, and photography labs designed to process the exposed film and produce photos. Various companies coordinated their services without explicit market exchange or hierarchical control in order to provide mutually complementary products and services to the customer. Likewise, the automotive ecosystem includes car manufacturers, gas stations, repair shops, driving schools, and governments that maintain the road infrastructure. Platforms, briefly mentioned in Chapter 4, represent the technical infrastructure that established data flows across in companies, as well as their products and services. Digital platforms enable the functioning of digital ecosystems. A useful distinction, introduced by Michael Cusimano, Annabelle Gar, and David Yoffie in their book The Business of Platforms, can be made between transaction platforms and innovation platforms. And hybrid platforms that combine the two. 36 Transaction platforms are systems that bridge buyers and sellers, such as eBay and Airbnb. Innovation platforms are systems that allow various actors to develop, run, and distribute different business processes, services, or resources. The Windows operating system is essentially an innovation platform that enables companies to create software. Finally, Apple's iOS and Google's Android operating systems represent hybrid platforms that enable innovation in the form of new apps and the matching of sellers and buyers through their App Store and Google Play Store. Companies can turn their existing digital products into platforms by creating modular interfaces to which other companies can connect. For example, the software company SAP has turned its corporate software suite from a fairly closed product family into an increasingly open innovation platform that allows other companies to develop, distribute, and run specialized applications that leverage customer data stored in SAP and some of SAP's computing capabilities. 37 Turning a product into an expandable platform provides a basis for a business ecosystem to emerge, with complementary and interconnected goods and services. Strategy in digital ecosystems. Ecosystems supercharge the data imperative, both in terms of omniscience, the reach of activities the firm can trace, and omnipotence, the scope of activities the firm can manipulate through software. The greater the ability of a firm to coordinate and control activities beyond its own boundaries, the greater the benefits it can derive from the analysis of data. For example, when Tesco started collecting detailed data on its customers through its Clubcard loyalty scheme, it soon built an ecosystem where it could leverage the scheme to direct suppliers' advertising to its most relevant customers. 38 Likewise, as logistics companies such as DHL and Maersk embrace digital data, they aim to create value by controlling an ecosystem of subcontractors' fleets, rather than investing in their own assets. Extending the data imperative to the external ecosystem can help a firm to secure profits from smart automation without investing in the real-world assets that are being controlled. Flows of digital data are changing the nature of ecosystems by creating deeper interdependencies and enabling real-time coordination. The automotive ecosystem has thus far involved generic and static interfaces. A driving school could teach students to drive any car because they all worked the same way. Digital ecosystems can involve sophisticated coordination between firms and their services outside business relationships. Figure 5.2 depicts the contrast between traditional non-digital ecosystems on the left, with digital ecosystems on the right. Although the figure is generic, I will use automotive manufacture as an example. Figure 5.2 Digital ecosystems break traditional supply chains within a traditional ecosystem. A car manufacturer, such as Volkswagen, would have purchased components for cars from its suppliers, for example, in-car computers and parking radars from Bosch. The car owners would buy complementary goods and services from somewhat disconnected third parties, such as tires from Goodyear and maintenance services from the local repair shop. In the digital ecosystem, the in-car computer systems may be powered by Amazon or Google, depicted as an ecosystem supplier in Figure 5.2, who have their own relationship with the customers. Moreover, complementers, such as car repair services and even insurance companies, can now have their own digital systems that allow them to connect to a car manufacturer's cloud database and download useful data about the past operation of a particular car and its condition. Finally, a car may have a built-in capacity for car-sharing services, which allows the car owner to lease the car to friends or strangers. Such a service requires interaction among diverse members of the ecosystem. Car-sharing payments would be likely to be routed through a complementary financial services company, while the car owner's insurance company would assess and manage risks. Access to the car would then be granted digitally by the car manufacturer's information systems, pending information from the bank and the insurance company. The primary reason for the growing prevalence of digital ecosystems is their ability to create superior value for customers. As modular designs often do, business ecosystems can facilitate the rapid recombination of services in ways that save money and add value. The availability of complements and the seamless interactions of products and services increase their usefulness and effectiveness. A mobile phone is infinitely more valuable when it can run applications and access services that are neither designed nor controlled by the mobile phone manufacturer or the telecom operator. Facebook, Uber, and YouTube make the smartphone much more useful for the user, but have no effect on its price. As companies become parts of ecosystems, the value they provide to customers becomes interconnected with their partners and complementers. Economists have suggested that we have entered an era of systems competition, where the competitiveness of a company cannot be understood without attending to its complementers. Point 39, for example. The relative attractiveness of the Sony PlayStation, Microsoft Xbox, and Nintendo Switch depends on the quality and pricing of games and diverse other accessories that third parties produce for them. With digitalization, the number and value of such complements is growing dramatically. Digital ecosystems create new business opportunities due to the ability of data flows to overcome the traditional boundaries of the firms, including those related to knowledge flows, coordination of activities, and control. Point 40 Salesforce, a provider of customer relationships management solutions, receives such fine-grained data about the sales personnel of its customer companies that it is probably able to create accurate insights concerning the strengths and weaknesses of the individuals employed by its customers. Sales activities, expertise, and productivity are captured through digital data and stored at Salesforce's cloud. Consequently, Salesforce may now have greater ability to understand and further develop the sales processes of its customers than those very companies themselves. Whereas the knowledge-based view of the firm, developed in the 1990s, suggests that organizations exist due to their ability to share and recombine knowledge. 41 digital technologies have made the sharing of knowledge and information across organizations as easy as it is within companies. At the same time, the open innovation paradigm has changed managerial attitudes towards knowledge leakages and normalized interfirm collaboration. Point 42 Data flows allow companies to develop sophisticated interorganizational routines with real-time coordination that would previously have only been possible inside organizations. The digital data flows in ecosystems allow products and services to complement each other in ways that were impossible in the pre-digital era, creating layered modularity, discussed in Chapter 4. These same data flows allow companies to overcome the boundary of control that tended to coincide with organizational boundaries. Research I conducted with Dr. Katerina Seppa, formerly of Aalto University and now at Lancaster University, revealed that digital data had enabled industrial companies to monitor, instruct, and dismiss their suppliers' employees with greater ease than their own employees. Today, the threat of negative customer feedback affords to Amazon customers greater control over third-party retailers on Amazon Marketplace than the control retail chain corporate headquarters could ever exert on their retail stores. In short, the new platforms and ecosystems are creating new opportunities to organize activities across firm boundaries. We are already seeing strategy processes and leadership activities turning from inside the companies to external partners and complements. The annual Facebook's F8 Developer Conference is simply one example of corporations' efforts to foster and influence their ecosystems. I believe this is simply the beginning of broader changes, as the Internet of Things and 5G communications technology will allow instant control of physical infrastructures across geographic and company boundaries. Summary: how the data imperative is reshaping organizations. This chapter provided an overview of the approaches companies are taking to reshape their organizational structures and processes to better leverage real-time data flows and the power of smart algorithms. These changes are summarized in Table 5.1. Table 5.1 Comparison of organizations before and after digital transformation characteristics. The 20th century industrial firm, data-driven businesses, strategic priorities, positioning within the industry, unique resources, such as brand and intellectual property, constant optimizing, experimentation, and development of external relationships, efficiency, division of labor, and effective management systems drive incremental gains, reinventing processes to pursue radical improvements, adaptability, run separate innovation units with mandate for exploration, semi-autonomous teams with a mandate to adapt and innovate, coordination managers and cross-unit meetings help align activities across different units, teams coordinating efforts laterally, strong vision and shared culture. APIs reduce need for coordination, control managerial systems designed to minimize uncertainty and to foster predictable incremental improvements, retrospective assessment of accomplishments, internalized norms, direct employees creative energy to appropriate and secrecy/transparency, limit information sharing to protect knowledge leakage, reinforce hierarchical authority, and reduce organizational conflict, radical transparency to maximize idea generation, coordination, and optimization across unit boundaries. Authority: individuals derive authority from formal and informal structures, such as formal position, social networks, or expertise. Individuals accomplish authority in situations by leveraging ties to other individuals, prominent ideas, and material entities, such as data-driven analyses. A central theme running through the elements comprising Table 5.1 is the gradual delegation of managerial tasks and responsibilities to employees. Experts, rather than managers, increasingly make plans, take responsibility for monitoring progress, coordinate activities, and search for relevant information. While this development is largely positive and makes non-managerial work both more productive and more meaningful, there are potential downsides to moving progressively more tasks to experts. One executive working at a large hospital group noted, exhaustively, how the organization did not need the agile team-based structures on offer. Rather, he thought they should reinvent a better bureaucracy. His point was that he would prefer his doctors to focus on practicing their field of medicine, rather than becoming multi-talented jacks of all trades, spending their time coordinating laterally with other healthcare experts. The public conversation concerning effects of digitalization on organizational structures and processes has been dominated by positive voices promoting self-managed teams and agile squads. These new approaches have been suggested as solutions for remaining competitive in the digital era. My intent in this chapter has been to provide a more balanced view and to highlight the risks and demands of team-based structures. Chapter 6 zooms in on the work that happens within diverse organizational structures and the effects that smart algorithms have on expert work roles and tasks. The data imperative: how digitalization is reshaping management, organizing, and work. Big data analytics has become a powerful tool for organizations looking to improve decision-making and gain a competitive edge. Throughout this topic, you explored how businesses use data to identify trends, optimize operations, and make strategic choices based on data-driven insights rather than intuition alone. By analyzing large datasets, organizations can predict outcomes, enhance efficiency, and adapt to changing market conditions with greater accuracy. You also examined how companies organize and manage data to ensure it is accessible, reliable, and valuable for decision-making. As technology continues to advance, the ability to effectively analyze and interpret data will remain a critical skill in business and technology fields. Moving forward, consider how these concepts apply in real-world scenarios and how organizations can use big data to innovate, solve problems, and drive success. Data is only valuable when it can be transformed into actionable insights. Organizations today rely on technology-driven solutions to analyze, interpret, and apply data strategically to improve decision-making and business performance. A well-designed data strategy ensures that businesses can harness their data effectively, optimizing processes and driving innovation. In this topic, you will explore the essential components of a strong data strategy and the tools, frameworks, and technologies that help organizations turn raw data into meaningful insights. You will examine key strategies for structuring and managing data, ensuring it supports business goals. By the end of this topic, you'll understand how businesses leverage technology to make smarter decisions, enhance efficiency, and stay competitive in a data-driven world. Technology plays a critical role in transforming raw data into meaningful insights that drive business success. In this topic, you explored how organizations develop data strategies, implement analytical tools, and leverage digital solutions to enhance decision-making. Understanding these strategies allows businesses to optimize operations, improve efficiency, and stay competitive in a rapidly evolving digital landscape. As data continues to grow in volume and complexity, having the right technology solutions and strategic approaches will be essential for making informed decisions. Moving forward, consider how these principles apply in real-world settings and how organizations can use data-driven insights to innovate, solve problems, and create value.